fasilitas riset, keamanan, dan kenyamanan dalam pelaksanaan kegiatan belajar mengajar juga menjadi prioritas Lab Desk Pro. Di antaranya dengan mematuhi protokol kesehatan saat pelaksanaan praktikum. Sebagai bentuk komitmen terhadap keselamatan, kesehatan, dan kepedulian, Lab Desk Pro mewajibkan setiap mahasiswa menggunakan perlengkapan standar di antaranya jas laboratorium, kacamata safety, sarung tangan, dan masker. Aktivitas di laboratorium dilaksanakan di bawah pendampingan dan pengawasan langsung dari Pranata Laboratorium Pendidikan atau PLP, serta dosen. Untuk menjaga ketertiban demi kenyamanan selama kegiatan pembelajaran, riset mahasiswa maupun pelaksanaan CDP. Pembelajaran berbasis aplikatif diharapkan akan memberikan pengalaman nyata kepada mahasiswa dalam bentuk simulasi dan pembuatan prototipe yang disesuaikan dengan kebutuhan pasar.
Pada sesi ini saya akan menjelaskan tentang solar panel. Perangkat ini fungsinya untuk mengkonversi energi matahari atau sinar matahari menjadi energi listrik secara langsung. Ini merupakan salah satu bagian dari energi baru dan terbarukan. Jadi tren saat ini mengingat energi fosil mulai menipis sehingga solar cell menjadi jawaban. Perangkat ini tidak bisa berdiri sendiri, harus dilengkapi dengan solar charge controller untuk mengatur agar listrik yang diproduksi bisa disimpan di dalam aki. Berikutnya, setelah tersimpan di dalam aki, listriknya masih artinya DC, agar bisa digunakan untuk kebutuhan listrik rumah tangga, perlu dikonversi dulu menjadi listrik yang AC dengan menggunakan komponen inverter. Jadi secara umum untuk bisa digunakan sampai ke end user ada minimal 3 perangkat: solar cell, solar charge controller, aki, dan inverter.
Untuk kondisi di lab desain dan prototipe ini sangatlah nyaman, yaitu ada AC, jendela, dan penerangan yang sangat memadai. Jadi untuk kita bisa nyaman untuk mengerjakan praktikum dan untuk pengerjaan GDP. Untuk pada saat pandemi ini kita tidak perlu untuk menggunakan AC, cukup kita hanya menggunakan sirkulasi udara dari jendela saja sudah cukup. Dan ada prasarana lain, yaitu seperti osiloskop, avometer, timah, solder, dan lain-lain untuk pendukung jalannya praktikum atau pengerjaan CDP itu. Dan untuk prasarana lainnya ada karpet dan juga wifi untuk bisa nyaman di dalam lab itu.
Lab Desk Pro juga dilengkapi dengan perlengkapan prosedur keamanan sesuai dengan protokol safety induction atau K3, di antaranya papan himbauan K3, alat pemadam api ringan, kotak P3K, jalur evakuasi, serta titik kumpul apabila terjadi kebakaran atau bencana alam. Strato adalah alat sistem pertanian yang sudah mengotomatisasi semua aktivitas budidaya hortikultura, mulai dari pembenihan hingga proses panen. Strato dapat memanfaatkan luas lahan tani yang sedikit, namun memiliki produksi panen yang banyak sehingga jauh lebih menguntungkan. Strato sendiri didesain dengan plant garden yang dilengkapi dengan beberapa sensor serta peran robot, elevator, dan conveyor belt yang memiliki fungsi untuk mempermudah mobilisasi tanaman. Strato juga dilengkapi dengan ruang central controller yang berfungsi sebagai tempat monitoring dan kontrol secara langsung pada rak tanaman. Seluruh fungsi masing-masing komponen memiliki sistem kerja secara otomatis dan fleksibel, serta dapat dikontrol melalui internet menggunakan smartphone. Teknologi penutrisian menggunakan ultrasonic mist maker yang menghasilkan partikel air yang sangat kecil sehingga mudah diserap oleh akar tanaman, serta penggunaan LED grow light sebagai pengganti sinar matahari dengan spektrum warna yang bisa menyesuaikan kebutuhan masing-masing tanaman. Berdasarkan data yang didapat, rata-rata tinggi sampel tanaman sawi yang diberi perlakuan metode pembudidayaan aeroponik pada strato adalah sebesar 3 mm dan panjang daun rata-rata sebesar 1 mm.
Strato merupakan inovasi rancang bangun pertanian cerdas untuk meningkatkan efisiensi budidaya pada komoditas hortikultura terintegrasi dengan robot dan berbasis Internet of Things. Nah, untuk fungsi dan kegunaan utamanya itu sendiri, Strato berfungsi untuk membudidayakan komoditas hortikultura dengan semua komponen dan aktivitas pembudidayaannya itu sudah berjalan dengan otomatis. Manfaat yang bisa dirasakan oleh petani itu mulai dari waktu pembudidayaannya. Mulai dari pembenihan sampai pemanenan tanaman itu jauh lebih cepat dibandingkan teknologi sebelumnya. Karena menggunakan penutrisian ultrasonic maker yang menghasilkan partikel nutrisi air yang sangat kecil sehingga diserap lebih mudah oleh akar tanaman. Dan juga untuk waktu pembudidayaannya itu sendiri dapat dipangkas jauh lebih efisien dibandingkan teknologi sebelumnya karena menggunakan pencahayaan LED RGB.
Sistem monitoring dan rekayasa kondisi udara pada kumbung berfungsi untuk melakukan otomatisasi rekayasa kondisi udara di dalam greenhouse budidaya jamur tiram putih. Tujuan akhir dalam penelitian ini adalah terwujudnya smart greenhouse atau kumbung jamur untuk budidaya jamur, di mana salah satu sub pendukungnya adalah manajemen air, suhu, dan kelembapan.
Jadi, alat kami bernama sistem rekayasa kondisi udara untuk kumbung jamur tiram. Secara singkatnya, alat kami ini berfungsi untuk mengatur kondisi dari udara di dalam kumbung jamur tiram secara otomatis, di mana terdiri dari suhu dan kelembapan udara. Manfaat dari alat kami ini agar petani dari kumbung jamur tiram ini tidak perlu menyiram kumbung secara manual. Dan juga alat kami ini memiliki fitur IoT di mana alat kami ini dapat memantau kondisi udara dari kumbung jamur tiram dari jauh menggunakan blink.
Inovasi Smart Mushroom Greenhouse atau sistem rekayasa kondisi lingkungan untuk kumbung jamur tiram dengan memanfaatkan sensor suhu dan sensor kelembapan untuk memonitoring rumah jamur apakah suhu kelembapannya sesuai untuk jamur. Data dari sensor suhu dan kelembapan akan diolah oleh microcontroller dan apabila tidak ideal, maka akan melakukan penyemprotan air dingin sehingga suhu dan kelembapannya menjadi ideal. Smart Mushroom Greenhouse juga terintegrasi dengan aplikasi Android sehingga petani jamur dapat mengecek rumah jamur dimanapun dan kapanpun. Dalam waktu 60 menit, alat ini dapat menurunkan suhu air sebesar 8,6 Celcius. Alat ini juga menjaga keadaan pada kumbung jamur agar tetap pada suhu 25 Celcius dan kelembapan 80%. Dengan adanya alat ini, diharapkan dapat membantu para petani jamur tiram untuk menjaga kondisi udara pada kumbung jamur, sehingga berdampak pada peningkatan produksi dan penghasilan petani pembudidaya jamur tiram putih.
Pengatur suhu dan kelembapan dalam hal ini budidaya jamur di tempat kami yang mana manfaatnya sangat terasa dan berguna bagi kami, khususnya untuk pengatur suhu dan kelembapan ini secara otomatis, karena dengan begitu lebih terjaga suhu dan kelembapan sesuai dengan karakter jamur tersebut. Terima kasih Elektro UB khususnya di dalam memberikan alat ini, semoga ke depan juga lebih bermanfaat lagi.
Robot sterilisasi ruangan berbasis sinar UV merupakan sebuah robot yang didesain untuk melakukan sterilisasi ruangan dari bakteri dan virus, terutama virus COVID-19. Alasan robot ini diciptakan adalah virus SARS-CoV-2 sudah meluas penyebarannya sehingga menginfeksi tenaga medis yang merupakan garis depan dalam penanganan virus ini. penyebab masih banyak terjangkitnya tenaga medis adalah sterilisasi ruangan di dalam rumah sakit yang masih menggunakan tenaga manusia, sehingga risiko tertular virus akan semakin besar.
Good morning and good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Okay. Welcome to this session of EECCIS 2022. Let me introduce myself. My name is Tri Norwati as moderator and MC in this session, and I will serving you today. Before we start to listen the presentation, I would like to you will be hearing a presentation from the first presentation from Mr. Waru Juryatno with topic transportation electrification. And before that, I will deliver biography, the first of keynote speech. Okay. Mr. Waru complete his basic studies at the Faculty of Electrical Engineering, Universitas Brawijaya. He complete his master studies at Universitas Gadjah Mada, and he joined the Universitas Brawijaya as a full lecturer, and he is currently the director of the Laboratory of Digital Laboratory, and his major research interests are advanced electrical power and fuel cell. And now he focus in transportation. Okay, are you ready, Mr. Waru?
Yes, Miss Titing. I've been here. Okay. Can you hear me?
Okay, thank you for your time, and video is yours.
Okay, thank you, Ibu Tri Nurwati.
Excuse me, I can hear your speech sound.
Okay, check. Okay, can you hear me, Ibu Tri?
Yes, I can hear you, Mr. Waru.
Yes, Mr. Waru, I can hear you.
Okay, thank you for the introduction, Bu Tri Nurwati. To the all audience, first I introduce myself. My name is Waru Juryatno. I'm a lecturer from Electrical Engineering Department, Faculty of Engineering in Universitas Brawijaya. For this session, I will give maybe a short presentation about my interests, especially in electric transportation, particularly electric land transportation. Maybe not too long, this presentation, only a few pages. Okay, let me allow me to share the screen. Okay, have you all seen my screen?
Yes, I can see.
Okay, this is the title of my presentation: Land Transportation Electrification. First, I will show you a brief history of the electric transportation. Okay, electric transportation is not a really new technology. The electric vehicle firstly made about more than 100 years ago. It is more than 1 century ago. So the first electric vehicle in form of electric train, which built by Siemens and Haskell, introduced at May 31, 1879. It's more than 100 years ago. And then in 1881, for a French inventor named Gustave Trouve built the first human carrying electric car. You can see here in form of tricycle. In this tricycle, Trouve installed a DC motor and electric source form is battery, lead acid battery. But and then some years later, in 1885, Carl Benz made his first internal combustion engine car or gasoline engine car given name Benz Patent Motor Wagon number 1. But electric car still flowering at that time. And then in 1899, the first automobile reached 100 kilometers per hour. The car name, I don't know the pronunciation. It's French, perhaps. Maybe it's spelled as La Semi-Content. It is the first automobile to reach 100 kilometers per hour speed. It's not a gasoline engine car. It is actually an electric car. So in a few years later, in 1901, in Texas, an oil well has been discovered, and it started oil boom, so the gasoline can be obtained easily and at lower cost. And then Henry Ford introduced the Ford Model T, which quote unquote affordable. Many people able to buy Ford Model T, which use internal combustion engine, gasoline engine. And so the gasoline engine car become more popular. The electric car popularity was dimmed because the battery technology are not developed well. So the electric vehicle development took the form as a train, or especially diesel electric train or locomotive. Diesel electric locomotive actually use diesel engine as the primary energy source, primary mover, but use the electric motor as a traction motor, as a mover of the wheel. So in the diesel electric locomotive, the primary energy source, diesel engine, but the transmission system using the electrical system. So it is the combination of internal combustion engine and the electric motor. Train popularity, electric train popularity electric train become more popular due to its speed and its lightweight, and then less pollutant, and also developing electric train easier than develop the electric car. But now, as you can see in latest year, still start from 2006, electric car become more popular. Pioneering by Tesla. This is one model from Tesla Roadster. It's introduced at 2006. Okay, we will see the diagram of diesel electric locomotive. We can see the part of diesel electric locomotive. The main part of diesel electric locomotive, diesel engine. This is the primary mover, primary energy source of the locomotive. But to move the wheel, the traction motor is used. Why to move the wheel, the traction motor is used? Because it is easier to transfer the energy from diesel engine to traction motor by using electric system. If a mechanical system used to transfer the energy or the torque from diesel engine to traction wheel, the system will be more complicated. Because it needs many gear system. So to simplify the transfer energy system, electric transfer energy system is used here. Compared to electric full electric locomotive, you can see here, the electric locomotive only need firstly the main transformer to change the voltage level from the about 25 kilovolt into 3 kilovolt value of voltage. And then there is main inverter to control the AC motor or the traction motor, which move the wheel directly. So in the electric locomotive, compared to diesel electric locomotive, we can get a smaller and lighter system. The heaviest part of the electrical locomotive, only the main transformer. It is the heaviest part. While in the diesel electric locomotive, the diesel engine itself, it is the heaviest part of the diesel electric locomotive. But the electric locomotive need a power supply from the overhead line or need special cable to supply the electric energy, because the electric locomotive doesn't bring itself energy source. Unlike the diesel electric locomotive, the energy source in the diesel electric locomotive stored on the locomotive itself. So the diesel electric locomotive have advantage, do not need power supply link, because the energy source has brought in the diesel electric locomotive itself. But it has disadvantage as follows. It produces emission gas, it's heavy, and the efficiency is quite low. Compared to electric locomotive, the full electric locomotive has advantages as no emission gas, and then lightweight, and its efficiency is quite high compared to diesel electric locomotive. So while the trains run on railway, if we refer to a car run on a highway, a road, land road, or maybe in any surface. So compared to a train, a car must be highly mobile, and then usually it needs to be compact and also lightweight. That's why the gasoline engine car became popular due to its high mobility, its compactness, its lightweight. But today we have a global problem. The problem we face globally climate change and global warming, which one cause of the climate change and the global warming, gas emission from the gasoline engine or internal combustion engine. So that's why today electric engine become popular again, because electric motor do not emit pollution, and also it's the electric motor are more more compact compared to internal combustion engine. But of course, there is a problem with the electric engine due to the storage, the energy storage. Okay, we can see here. We can see here the energy densities. We can compare the energy densities of gasoline and diesel compared to battery, especially the lithium-ion battery and zinc-air battery. While diesel and gasoline has a energy density about around 45 or 40 something millijoule per kilogram, or you can see here about 35 millijoule. Sorry, that's not millijoule, megajoule per liter, and 45 or 40 something megajoule per kilogram. Compared to lithium-ion battery, we can see here, lithium-ion battery energy density is only some megajoule per kilogram and some megajoule per liter. So this is the main problem. This is the main problem of the land transportation electrification. Okay, regarding the engine itself, actually the electric motor has more advantages compared to internal combustion engine. You can see in this table the comparison of internal combustion engine and electric motor. If we see the efficiency, most internal combustion engine has less than 30% efficiency, while the electric motor has 60%, more than 60% efficiency. And also, if we see the dimension, internal combustion engine usually have a large dimension compared to electric motor with the same power capability. Electric motor has a relatively small or smaller compared to internal combustion engine with a similar power. And also the weight. Internal combustion engine usually weight due to the material used to build the engine. Compared to the electric motor, internal combustion engine is heavier than electric motor on the same power rating. And usually, the internal combustion engine has large part numbers. As you can see in this picture, this is the diagram of an internal combustion engine. There are so many parts needed to build an internal combustion engine. Compared to electric motor, only small parts needed to build an electric motor. So the maintenance cost and the internal combustion engine relatively high due to part number. But the electric motor maintenance cost actually low. The electric motor maintenance cost. But if we see in the context of electric vehicle or electric car, especially in electric car, where the batteries needed to store the energy, the maintenance cost will be high due to usage of batteries. Batteries should be replaced after some operation time, or precisely operation cycles. For example, lithium-ion batteries need to be replaced after 3,000 cycles, charging and discharging. And the cost of the lithium-ion battery is really high. That's why I mentioned here the maintenance cost of electric motor is high. But actually the maintenance cost of the electric motor itself is not really high. It's quite low compared to the internal combustion engine. And the operational cost mostly the cost of the fuel cost, the energy cost. Fuel cost today is relatively high compared to electric cost, electric energy cost. 1 kilowatt hour in electric energy in Indonesia, 1 kilowatt hour energy price is about 3,000 rupiah. While 1 liter fuel, perhaps pertalite fuel today is about 7,650 rupiah. If we convert the energy, the electric energy cost is about 3 times or more lower than the fuel, than the gasoline energy cost. That's why the operational cost of internal combustion engine much higher than electric motor. Now, that is why that is the one reason. What is the weakest reason why the electric vehicle, particularly electric car, today become popular? Because today we want the car to be more environment friendly due to global warming and climate change. We want a car that is more efficient and especially low cost. Indonesian people is sensitive to operational cost issue. If Indonesian people can realize that electric energy is cheaper, more inexpensive than the fuel or gasoline energy, perhaps Indonesian people will change their vehicle to electric vehicle. But there is one obstacle. The primary obstacle of the acceptance of electric vehicle by Indonesian people, especially from the price, the sale price. Compared to gasoline engine car, the sale price of electric car much more higher. The price of an electric car mainly determined by the battery cost. That is why we need to develop the battery so it will be more compact, more light, more compact and lighter, and can be charged faster, have a higher life cycles. And other disadvantage from the today battery. We hope we can develop the more compact, lighter battery, have a faster charging process, higher life cycles, more environment friendly, and especially more inexpensive. Because the one main issue of the electric car, or perhaps electric vehicle in general, is the energy storage cost. Or to be simple, the battery price. That is the main issue. And also to make the exception of the electric car more easier, we need to change the electric infrastructure, because the electric car or electric vehicle need special charging infrastructures. And also this is the problem today is primary energy sources for the electric generator mostly come from coal field generator. That is why some people who do not want to change to electric car or electric vehicle, they say the electric vehicle do not really environment friendly, because the primary energy source are from coal field generator. So that's why some people say the electric vehicles not really environment friendly. And some people also think climate change and global warming, that's not real. they are only hooks. And also, especially the oil industry, of course, the oil industry do not want to change the situation. They want to preserve the status quo. They want to still exist, still be exist. The industry, the oil industry, don't want to be vanished. That's why they fight many parties from oil industry fight the electric vehicle because it can be threat for their existences. Okay, but the last word. But however, we can reject the future. The future is inevitable. So we now need to adapt so we can face the future. We can live better in the future. Okay, that is all from me. That is my help for electrification of the transportation, especially land transportation. There are some problems, but I think we can solve the problem. Perhaps in 10 and 20 years from now, electric vehicle or especially electric car will be something we can accept easily. Okay, that is all from me. I give back the screen to Ibu Tri Nurwati. Thank you very much for the attention.
Okay, thank you for your presentation, and it is very interesting presentation. Any question maybe from audience? Okay, excuse me. Okay, from Eco. Excuse me. Do you think V2G concepts with the battery charging, discharging, short life cycles? Excuse me, Mr. Waru. There is question from chat.
Okay. Perhaps I don't know. This is Mrs. or Mr. Eiko. Can you tell me about the V2G concepts? And pardon me, I never hear the V2G concepts. The V2G concept.
Excuse me. Okay.
Oh. Okay, V2G. Okay, from vehicle to grid concept.
Okay.
Yeah. Battery life cycles determined by the structure of the material used to make the battery. So it has been determined, so we cannot prolong or add the life cycle of the battery. If we use the V2G concept or bidirectional, bidirectional grid, as long as the cycle charging, discharging cycle is not added, I will. It is not a problem. The problem if the charging and discharging process decrease the life cycle. Every time we charge a battery, we decrease the life cycle number of the battery. But discharging is not affected. It's not affect the life cycle. It is only the charging process that is that affect the life cycles battery. So as long the V2G concept here do not decrease the life cycles, I think that will be not a problem. That is my opinion about the V2G concepts, whether it is switch the battery charging, discharging or not. So okay, there's the question from Mr. Effendi Dodi Arisandi. Yeah.
The second
Okay, the opportunity
question.
Yeah. The opportunity of our country to produce battery. So yeah, in my opinion, there is a possibility for us, for Indonesian people, to build or to produce battery by ourselves. What we need to build the battery is mainly the lithium substance. As long as we have the lithium mine, I think we can build or we can produce the battery itself. But of course, we must master the technology or the knowledge to build the battery. As far as I know, there are some universities which have a concern to develop or to master the battery technology, to master the battery manufacture technology. As far as I know, the UNS or Universitas Negeri 11 Maret in Solo, they have the research. They have researchers who focus on battery build, especially lithium-ion battery. And our country research institution, just like such as LIPI, the researchers from LIPI also focus on battery manufacturing technology, especially lithium-ion battery. There are some researchers in LIPI who focus on battery lithium-ion battery manufacturing technology. That's why I think we have a great opportunity to produce the battery ourselves. Okay, that's my comment to Mr. Effendi dari Arisandi question.
Okay.
Okay.
Thank you, Mr. Waru, and thank you, Mr. Effendi. Okay, it is enough, Mr. Effendi. How are you?
Yes, enough. Thank you for
Okay,
your
Mas
answer.
Effendi, thank you for
Yeah,
your
thank you,
question.
thank you.
And I see
Okay.
there is one more question from
Um,
Mr. Indra. What kind of
okay.
batteries do electric vehicle uses? Okay, mainly the type of batteries used in electric vehicles, lithium ion type battery. Why lithium ion? Because lithium ion has a higher energy densities. So as I mentioned in my presentation, we need a car size that compact. So if we build an electric car, we need the battery to be compact, or the battery must have a higher energy densities. That's why the mostly used battery in electric car are lithium ion kind. We do not prefer the lead acid type because the energy density is much lower compared to lithium ion type. But refer to the graphic, energy density graphic in my presentation. The battery type that has higher energy densities than lithium ion type is zinc air or metal air battery. But as far as I know today, of course, some researchers have built metal air battery, but it's only in a laboratory scale. For mass production scale, we can get the lithium type battery. That is why for today, most electric vehicle use the lithium ion type battery. Okay, that's my comment for Mr. Indra. Thank you for the question.
Okay. I hope it is enough for this presenter from, and then thank you very much, Mr. Waru Juryatno, for addressing this interesting topic. And okay. Okay. Next, before we get started for the second keynote speaker, I will introduce him. His name is Mr. Dr. Raden Arif Setiawan. Okay, I will deliver his biography. He received the bachelor degree from Universitas Brawijaya, and then next the master degree from Universitas Indonesia, and next he finished the doctoral degree from Universitas Brawijaya, and he is currently the head of data and infrastructure division in Universitas Brawijaya, and major research interests are embedded system design, computer network engineer, system analyst, data analyst, and IoT. And for Mr. Raden Arif, place is yours. Time is yours. Okay.
Okay, thank you, Putri. Can you hear me?
Yes, it is clear.
Okay, thank you very much. I'm sorry. I think I have a little bit of problem with my connections. May I share my screen? Okay, can you see my presentations?
Yes, of course. I can see.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thanks to Putri and all the EECCIS committee and EECCIS participant in this for this very good opportunity for me to share my maybe my knowledge and my experience, especially about the IoT in agriculture. So let me start a little bit. So this is the outline of my presentations. The first about the introductions, maybe a little bit about the why I choose this topic as a very important topic for us. And the second about the agriculture and the food and demands. And third about the IoT and AI for agriculture. And the next is case study. I will try to pick up some of my research and my experience with collaboration with other researchers from Malaysia and from Japan and etc. And the last is case study and conclusions. Okay, I picked this data from the UN. So we can imagine that the world is growing, the population is increasing every year, and United Nations predict that at 2050, the number of people will be 9.6 billion. That's the biggest problem, I think, because the biggest questions is how to produce enough foods for them, because there will be a big problem if the increasing of the populations is not followed by the increasing of the food supplies. So we can see in the world that it keep increasing like right here, and we can see at the right chart that we need to improve the productions of the agriculture product to supply to achieve the demand that need by human. That's the UN says. But let's see what the real problem. The real problem, the first is the water level are receding. So we hear that in some farmers it's hard to get water in recent day. And the next is agriculture land is shrinking. I think we all understand that so many agriculture land is changing to the home land and for the home for industry, etc. So that's why that's the biggest problem also. The third is environment is degrading. We understand that there is a climate change. In Indonesia also, I just discussed with the farmers in Batu area that they also confused because usually in August there is no rain, okay? But the problem is in nowadays we know that maybe in Malang especially 2 weeks ago there is a hard rain in Malang or Batu area. That's a problem for the seeds or the growth of the plant that usually they have to bloom, but they cannot work as usual. Okay, and this the last important things is the numbers of farmers is decreasing because so many young people, they choose not working in the farmers area. They choose working in other field like industrial and something like that. So this is the chart from the BPPS, Beda Video Statistic, and we also know that this is the number of the farmers keep decreasing, and also the land is decreasing. This is the biggest problem, I think. Also this is the word problem, but it also, if we look at our country, then this is the problem for our country. And this is the biggest questions: how to increase the productivity of agriculture with the limited resource in sustainable way. I think we need to emphasize the sustainable way, because of course maybe we can improve with a traditional way, like increasing the agriculture land. Of course, we need to reduce the forest. It will become next problem. It will giving another problem to ecosystem. And the second, maybe farmers usually use increase the volume of fertilizer. They think that the more fertilized, they can produce more foods for people. But the problem is, the more soils, the more fertilizer could destroy the soils, and the impact to the nature balance. So this is also the biggest problem. Next, about the pesticide. We know that to keep the plant from the insect, they try to use the pesticide. But we also understand that pesticides is bad for environment. And the last, I think we know that the difference between the farm field in Indonesia and farm field in maybe in US and in Europe and something like that. Usually farmer only have limited, very, very limited area. So that's why it's also almost impossible if the farmers buy the heavy equipment like tractor, because tractor need a big land. But the problem is the condition in Indonesia is not suitable for these conditions. Okay, and the next is, we know that the improvement of technology is driven by industrial revolutions. The first industrial revolution in 1784 is about the implementation of the mechanical production in industrial field. So they try to change all the aspect of the manual things to mechanical things. And the next, in 1870, the second revolution industrial, the implementation of electrical and mass production. So they try to change from the maybe steam machine to the electrical machine to drive every device or every equipment that requirement to produce something. Okay, and the third industrial revolutions around in 1969, we understand that there will be a new technology like a programmable device, and there is also the internet is starting to launch and used by human, etc. And the last 2 days, we facing the fourth industrial revolutions. We know that one of the concept of cyber physical system between the internet and the real world is mixing together. Okay. So all device is connecting together, all device creating data together, and that's why we need many new term of technology trying to solve those problems, like the big data, artificial intelligence, Internet of Things, and etc. So that's why the years between these industrial revolutions, if shortage, so maybe we will facing the next industrial revolution in very short years than now. Okay, let me discuss about the IoT. Actually, the concept of IoT, IoT component is not a new things, because there will be many findings before we heard the concept of Internet of Things. we know that the Intel trying to build the first processor in 1971, and also Nikola Tesla. They in 1926, you can imagine that one of the futurists that he said that when wireless is perfectly applied the whole earth, maybe I will emphasize the last word. A man will be able to carry one in his vest pocket. I think as we what our daily life today is, we always bring our cellular phone in our pockets. So he already say this concept since 1926. And the next, we understand that in 1969, the first internet is releasing. But if we talk about the wireless connectivity, in 1894, the Guglielmo Marconi is starting to begin development of the wireless telegraph system using radio wave. So also similar with the radio system that we are using today, but of course with many improvements. And when we heard about the internet, the first initial internet is designed for the human and human communications. So they try to build a system to change the telephone system, okay? And the first ARPANET link that established between the University of California and Stanford is around 29 October in 1969. What they try to send, this is in the bottom left. We know what they send. They just send three letters. The first is L, trying to send from California to Stanford. Yes, it's successfully sent. Okay. The next word is O. Yes, it's successfully sent. And the third, when they try to type G and the system is crashed. But however, this is a big milestone that communication between two nodes can be utilized the cable network. As we know that today's we cannot living without internet. So I think all of the participants here also have the social media. They also have the communication device like a WhatsApp, Google's, Instagram, etc. And all of them is based on the internet. The next, not only communicate between human and human. The next era is how the device can talk with another device. So what that means that internet is used for things to communicate between things. So maybe we know that many of our device and can connect to the internet and can send the data to the dashboard and we can monitor. So that's why the concept of the Internet of Things. Okay, if we look detailedly about the IoT ecosystem, then the first is the things itself. What is the things? Actually, the things is a device that has the sensors, that has the actuators, and it become the data sources. For whom? It's for the data. So it can measure everything. It can read the sensors and send the data to the server. Of course, if we talk about the sending the data, then we need to talk about the communications, okay? So the sensors will be captured by the controllers, or we call it the edge processing. So we already understand that there are so many chip modules that support the IoT, like the ESP32, Raspberry Pi, and something like that, that can read the sensor directly, and it has the ability to connect to the internet. So it can directly connecting to the wireless network system. After this device is reading from the sensors, the data will be sent through the communication system. this is the third step, which is we know that there will be so many options for the communications. The first is wireless communications. Of course, this is the important things. So we can use the wireless to send the data to the IoT hubs. We can call it IoT hubs, because this IoT hubs is a device that's connect between the device itself, the things itself, to the server. Okay. After sending data to the server, then what next? This is the biggest questions. After we collect so many data from the sensors, what will we do with the data? We can imagine that if every minutes each device sending the data, then how many data that we have to collect in only 1 day? That's why we need the technology we call the big data. Big data is a part of the whole system. After collecting the data, of course, we need the technology to analyze, to improve, and to give the feedback to the things itself. So we can use the machine learning, artificial intelligence, and any algorithm. I think so many researchers already work in this field also. Okay, that's a sample of the IoT ecosystem. This is the example of the things. The important things of things, okay, is it has the controller, which read the data, and it can communicate with the wireless, and it has also the actuator. For example, if in agriculture, maybe it can read about the condition of the soil, and if it's dry, then it can ask the pump system to try to irrigate all the area that dry. Okay. The second is communication. It must have communications modules, because we need this device has to communicate with others. Okay. And the third is one of the big issues is power management. How the device can use the limited power, so it can use the power efficiently to make this device is live, but it's also working properly to send the data from the sensors to the server. The next is also sensing. We know that there are so many sensors that can be used for the things like the temperature, humidity, water level, pH, GDS, camera, etc. And also there are so many options for the technology for communicate, like Bluetooth, Wi-Fi. Maybe if Wi-Fi has a very limited range, then we can use like a LoRa, Sigfox, or if we need a more broad area, then we can use the GSM, NB-IoT, etc. It's depend on the condition. We cannot use that Bluetooth is the best or Wi-Fi are the best. You cannot say something like that, but we have to understand about the conditions of the area, and we have to choose the best communications system that suitable with the system that we provide. And the next is communications. We know that there are so many format of communications, like maybe, and this communication is evoluting almost every years, right? We cannot use 2G cellular phone right now, something like that. Like a technology, you can use 2G or 3G using cellular band and data rate 10 Mbps, something like that. And the range, of course, because we are using the cellular system, the range is very wide, around several miles. Okay, but the problem is high. The cost also high. So we can choose between this one. And the second is Bluetooth. Bluetooth is designed for the short range communications using 2.4 gigahertz frequency, and data rates around 1 until 3 megabytes. And of course, this is increasing because we find the new type of Bluetooth with the higher communications. The power usage is low, and the cost also low. Okay. And we know the next is LoRa. I think LoRa is become one of the most promising technology, but unfortunately, the regulations just, I think, in 1 or 2 this year just released new regulations about the frequency of the LoRa. But the problem is LoRa is only suitable for the low data, less than 50 kbps. It's good for the data, but it's not good for if you want to send like the image, something like that. And the next is LTE, NB-IoT. NB-IoT is actually the IoT concept that embedded to the cellular band. Okay, so it used the cellular provider, usually used by NB-IoT. Okay, the next is Sigfox. Sigfox is have a business scheme similar with the NB-IoT, which is there always have a provider to provide the Sigfox. Okay, and the next is Wi-Fi and Zigbee and Z-Wave. I think each of these protocol, each of these technology have the cons and pros there. Sometimes you need to choose it properly to implement in specific case problem. And then the middleware. We know that there are so many middleware that already exist in the internet. We can also use some platform that are free to use, like Google, like Blink, ThinkSpeak, something like that. We can use it some freely for, of course, for the some amount of data. But if you need the largest data, then you need to consider another payment solutions. Okay. And the important things is the scale of the implementations. If you're just using one device or two device or 5 device, and you think that the number of data they produce in one time or in one day is not really big, you can choose the free solutions. But you can imagine if you try to implement thousands or 100,000s or millions nodes, then I think the free option is not suitable. So maybe you can default build. We have to build by ourselves or using the current with the proven solutions like the Google Cloud or the Microsoft Azure or AWS. AWS is also providing the IoT system. I will tell you later. The next is dashboard or analytics system, because this is very important when you try to collect the data and what next. The important thing is you want to see about your data, right? So that's why we need to display the data by visual or something that easily to understand about the trends. Okay, so maybe like in the right chart, you can see the movement of the temperature, movement of the sunlight, movement of the humidity, etc. So maybe if you are a farmer, or you can suggest the farmer how to solve the problem with this one. Also, we have the local brand of the middleware. Telkom has an Antares. Maybe you can try to access and use it. It's also free for a small amount of data. Or you can use the Flex IoT. It's provided by BTXL. It's also, maybe you can discuss with the XL to provide this one. Okay, the next step, after you collect the data, you can display the data. The next is how to analyze the data. Okay, of course, we need some of the algorithm to implement in this data. You can use the machine learning, a prediction model, text-to-speech, everything. Okay, so it's also almost all of these features is already provided by a big IoT provider like the AWS, Microsoft, or Google. They already provide the tools for machine learning, for example. So you can just use the algorithm and you can try to train itself, and it can give you the result based on your data. Okay, next we talk about the IoT itself. Okay, if we watch this chart, then there are some emerging technology of IR in industrial revolution 4.0. But the top is the IoT, because IoT is a trending new and it's deployed almost everywhere. The price is some of device is cheap, so you can just buy it, because not every people in house need robotic, right? But for the IoT, maybe you need to turn on your light remotely, by using your smartphone, or you want to turn on the front light, or you want to turn on the air conditioners in your house remotely, etc. It's something like that. Okay, so it's cheap, and the industrial requirement for this one is very, very big. That's why the word growth ID prediction based on the Vodafone research will be increasing every year. I think IoT is a big challenge, a big opportunity for us, especially for the electrical engineering students or the electrical engineering researchers, to trying to produce something that can make easily human life. Okay, if we talk about the IoT itself, there are so many areas that required by many industries. And one of the biggest is smart city. So smart city, it's because usually smart city is owned by government. So usually government need to increase the efficiency, how to use the resources. So usually they implement the IoT, for example, for the street light, to control the street light, and to control, for example, for the traffic light and something like that. And the second, for the industry. Almost all industry will move to the IoT concept, because with IoT, they can measure everything almost in the real time conditions, and they know what happened with the system, and they can give a feedback as soon as possible. It's not waiting for until one cycle is finished. The third is connected building, connected car, etc. And the number 9, it's smart agriculture. Okay, why I choose the smart agriculture requirement is maybe it's a bit low compared with others, but based on my first slide of the presentations, the smart agriculture is very, very important to increase the food production that will be required by human, because every person need food. Then the question is how to improve is using the technology. Okay, so this is the growth of the smart object. So we can see that there are so many smart objects, so many smart devices already implemented, and it keep increasing. So don't worry about the things, because in the research in this area is very promising. Okay, now I'm sorry, I'm still writing in Indonesia, because this is actually the opportunity of the IoT in Indonesia. As we know that I already mentioned to you all about the Industrial 4.0. I think I don't need to improve this again. But this is the step to for the starting to build the IoT. The first, we need to understand the use case. For example, I want to build an IoT system for maybe for the crops growth, or for automatic irrigations and something like that. We need to understand case. What is the sensors needed? What is the problem? And what kind of actuators is required in the system? The second is try to build a prototype. Prototype is very important to prove that our concept is working properly. The third, it will test, trying to put the system on the field, and it's right, because usually in theoretical and the implementation is very, very different. I have an experience that some of students trying to develop a system to detect water salinity at the oceans on the beach. But you know that on the beach, there are so many problems there. So it's not working properly. Maybe in first week, it's okay, but the next week, the system will not work every day. That's why we need to really understand about the conditions of the field and what type of the device that we can put. And the next is improvement. The last is monetize, because the monetizing is very important, because if we talk about the IoT business, it's impossible if we're not talking about the business itself. So the IoT will increase, there will be more demand if the monetize is working properly. Okay, so when you try to develop the IoT models, there are so many steps here. Maybe first we need to think about what is the things itself. So what is the sensors, what is the actuators, etc. The next we think about the connectivity, what kind of the connectivity you will use. The next is middleware. To which server, which middleware this data will be sent through. Okay. The next is IoT service. Okay. The last is apps. What kind of apps that we will use to show the data to the users. This is very important things. Okay. This is the example. So if I want to, for example, to design something, then I will need sensors like the temperatures, light sensors, and moisture sensors. Okay, and also I need the actuators like soil sprinkles or the servo or something like that. The next, for the connectivity, you need to decide about what type of connectivity you need required for this. For the XP, Ethernet, API, etc. The next is middleware. You need to choose the middleware you will use. The next, also you have to understand, because there are so many middleware that offer the free, and there are so many tutorials on the YouTube, and you can download the documentation easily, try to implement freely. The next is IoT service that you required, and the last is application that will be used. Okay, so that's all steps to design the IoT things. Okay, the last is IoT in agriculture. I'm sorry, Butri, how many time did I have left?
Oh, excuse me, and you have time until 11 o'clock.
Okay, okay, thank you very much. Okay, the next I will discuss about the IoT in agriculture itself. Okay, so maybe it just I want to share about my experience, maybe with the implementation of the IoT in agriculture field. Okay, the first we need to know about the agriculture cycle, because the IoT will each of the cycle has its own cases, and you can provide the solutions, IoT solution for each case. The first, for example, the preparations of soils. Before the farmers trying to plant the seeds, they need to prepare the soils. They need to remain the conditions of the soils. That's why maybe some of or each part of the area. Okay, sorry. Sorry, can you hear me? Because I have the notification that my internet connection is problem. Okay, thank you.
Okay.
The next is irrigations. We understand that all plants need water, so irrigation is very, very important for this case. Okay, so irrigations and fertilizations is two parts that important also for the when the growing plants. The next is weed protections. This is also the biggest case. When I discuss with my friend, which is a farmer in Batu area, the problem is how to protect the weed sustainability without the medicine or without the fertilization. That's the problem. So maybe some of researchers trying to create like a sound or building a frequency which is can reject the insect from to eat the I mean the fruit, something like that. So that's problem. The next is harvesting. Harvesting means after this flow, they try to take to harvest all the seeds, all the plants, and trying to sell. The storage also is very important. Storage is you need to keep the temperatures, you need to keep the humidity and protect it from many animals that usually eat the plant itself. Okay, this is one of the project that I working with some partner from the Malaysian, from the Kyoto University, and from the Myanmar. We call it the FarmTap project. Actually, this is actually a precision agriculture system using IoT and artificial intelligence for urban farming. Okay, the first target of this project is for the urban farming. So we built maybe in the small system in the housing or in a small area inside the house. Okay, so we built this system, and also we try to develop sensors to measure like a pH level, temperature level, humidity, moisture, etc. Then all the data that collected from this system is trying to analyze using the FarmTap AI system. Okay, so it's also working together between so many universities. This is the block diagram of the FarmTap, which is we have the sensors, so many sensors here, like temperature sensors, pH, EZ, ORP, and etc. Okay, and this sensor is connected Raspberry Pi. We also use the Raspberry Pi cameras to detect the growth of the plant. So we can just capture the crops every maybe every 4 hours, actually, if I'm not wrong, 4 or 5 hours. We take pictures and trying to compare between previous pictures and the next pictures. If there is a change, then the seeds or the plants or the crops is growing, working properly. Okay, so it also connected the water pump. This is to maintain the irrigation is enough, and all the system is connected to what we call we try to use the Amazon service to provide the platform, the IoT platform, and we developed the web application that we call the FarmTap, and this also can monitored by the cellular phone. This is the selfing system that we built, and some of them, like in Malaysia, they use literacy to growth, and Unhas using the red spinach, and us in UB using the bokchoy to grow these crops. Okay, so actually it is just a simple selfing system. Some of them is very small. In some area, it's bigger than this one. But the important thing is all of the system is sending data through the FarmTap. FarmTap is the application or the platform that we built together to provide the open system for the farmers. Actually, that's our goals actually. Okay, in the platform, in this FarmTap platform, we can check every data. We have the real-time sensor data like a temperature, pH, EZ, CO2, and etc. And we also have the historical data to show the impact of each of the parameters to the growth of the seeds. We try to develop this one to we discussed with some farmers actually. Okay, We also try to develop the system to monitoring the growth of the crops. So yeah, maybe we just trying to implement the simple background removal algorithm, trying to remove background and try to check the difference between the background and the foreground, and try to measure how many space, how large the space that utilized by the image itself. Okay, so we use this is the algorithm of the growth monitoring system, but actually we're using the shortest one from start, and we use the pro-processing to adjust the brightness and etc. And then we try to extract the green channel. Why? Because our case we are using the bak choy, so we need to extract the green level, only the green level. But of course, maybe in the another case we can use all channel, but in this case we are only using the green channel. The next, we are using Otsu thresholding to get the edge of the plants. And the next is try to calculate the number of pixels occupied by the crop itself. And we try to measure between the size and threshold, and it's stored to the database. Okay, I hope this is the video of our system. It captures the crops every 5 hours, and we know that the crop is growing. Okay, then after growing, we know that it's occupied a couple area that converted to black and white, and using the same algorithm, we can try to measure whether the crops is growing or not. It's try to compare between the rate of growth with the conditions of the nutrient. Okay. Okay. So we try to measure the right side. As you can see, this is the first week, the 13 days, and it's 17 days, 21st days, until the 33 days. We try to measure the percentage of the area that not that occupied by crop itself. So when we check day by day, then we can see that maybe in some cases that the crop is growing fast, but in some cases the crop is not growing very fast, and it can be tried to analyze with the compositions of the nutrient itself. Okay, this is the image processing of the data, and we send the data through the farm tab here, so we can the rate of growth as using the line chart. We know that when the plant is not growing as expected, but when the plant is growing faster than expected. This is the report. So the report is saved on the AWS cloud server. The format is standardized. So each of partners, so we are in Malang, in Brawijaya, and our friend in Makassar, our friend in Malaysia can gather data together, and they can analyze all the data together. Okay. So after the implementations of this project, we try to share what we are findings to the farmers. One of the goals, how to socialize, how to introduce the farm tab platform to the farmers. We try to invite some of the young farmers from the Batu area and also from the government. And we also publish some of the papers to some of them are very, very interested with our project. So they invite us to train and try to deploy the system in their field. Okay. And then the next is we try to develop a system in the real field, because previously we used develop in the a very, very small area, The next is trying to deploy in the largest area. We try to implement this in the real field. Then fortunately it's working. So far the farmers can monitor what happened with their soils, what happened with their plants by remotely. Okay, yeah, they also can take actions if there is something unusual with their plants. And the next, after learning about that case, okay, as I already explained before, that the preparations of soil is very, very important. So we try to implement further with this FarmTab platform to the agriculture field. Okay, so FarmTab, we try to use the system in the real agriculture. After we discussed with the farmers, they said that the NPK sensors is a very, very essential nutrient for any plant. Any plant required NPK sensors. That's why, because the problem is the overuse of the NPK nutrient could destroy the soil. So we need to precisely measure how many NPKs fertilizer that suitable to implement and that soils. That's very important. So that's why we need to measure NPK. The problem is, this is the challenge. Okay, we can build the NPK sensors because I've been by, maybe you can buy in China or something like that, just develop the device that measure the sensors. But the problem is, usually the concept IoT for the land is to deploy the sensors almost everywhere. That's the biggest challenge. If you put the sensors maybe every 10 minutes, of course, if we talk about the precision agriculture, it must be precise, right? But how precise? That's the biggest question. That's why current term is not using the precision agriculture, but they're using the data-driven agriculture because it more broadly, it's more easier to understand. If we use this device in the field of the agriculture, the question is how many devices that we have to deploy in the land. Of course, it's impossible if we have to put the device maybe every 10 meter or every 100 meter, etc. Because the price will be very, very expensive, and the farmers will have a problem with that because the revenue is not equal with the price that they have to spend to buy the device. And then the next is they try to deploy the sensors every 10 minutes. Okay. The second challenge is using drone. Okay. There is some discussion also the implementation to using the drone to measure the agriculture land. That the drone is good for the wide area monitoring. So, for example, if you want to check the growth of the plants, maybe similar with what we did before, but with the largest area, maybe we can use the drone with the camera. Drone also good for fertilizing. So maybe you can use the drones to carry on the fertilizer and try to distribute the fertilizer to all part of the plants. But the problem is, measure is the problem for the drones because the drone flying high from the land. In fact, the farmer required the measurement of the soil itself. Then we try to bring the solutions. Okay, so we try to build sticks based on the GPS and the NPK sensors. These sensors can read the NPK data almost instantly, maybe in just requirement around 1 until 5 seconds until the measurement is stable. Then it can send the data to the server. So with these sticks, farmer doesn't require to buy so many devices because we know that the area of the farmers is not as wide as in other countries because it's maybe they have only very limited area of agriculture, so they can just walk around and while bring this device, and they try to put device, try to snap and stick the sensors to the land while walking. Okay, so after that, because this device has the GPS also, this device send the data to the server. Not only the measurement of data, not only the data from the NPK and also the soil conditions. They send the GPS also. So that's why we can try to draw the map between the land image, and we can overlay with the NPK conditions. So with this data, the farmers can precisely give the soil nutrient to the location that required more than others. So because this is NPK, then they can use the N, it's N and P and K differently. So that's why how. Of course, the measurement is not very precise. It's different with the laboratory measurement, right? Because I already tried to compare between this device measurement and the lab measurement. It's very different. Maybe the result of this device is not as precise as laboratory, but at least the farmer already feel that this product is very important to them, because they can just give the requirement nutrient to each area that required. They don't use this fertilizer nutrient to all area. That's why, because you know that nutrient price is getting higher and higher. That's why. Okay, and the next is maybe this is the solutions for harvesting and storing, because we already discussed also with the UMKM at Batu area. Okay, they usually have a problem about this harvesting, storing, and sorting and something like that, because usually the device or the equipment to automate this system is very expensive and it's not suitable for them. That's why they requirement the very simple solutions that can improve the productions. So that's why we try to build this device. Actually, this device is just we try to improve the system by using the camera and try to detect its of fruit, about the size, about the grade, and something like that. Because grading is very important for the market. Because I already discussed with a friend in Batu that market like Hypermart and Lila, etc., has a different standardizations about the size and the heaviness of the fruit. And this is the result, actually. After discussing with farmers, they said that after they implement our system, they said that the increasing is very meaningful. Okay, so it's increased very high than before using the IoT system. Okay, so the conclusions of this, actually first, the demand of the food agriculture is very increasing. So I think, yeah, I hope that because the food agriculture is very important for our life. And I remember that when the COVID-19 pandemic has happened, there are only 3 sectors that survive. The first is medicals, of course, because COVID requirement the medicals treatment. The second is the online market, of course, and the third is food, because everyone needs food. That's why if we have a business in the food, then I hope it will be requirement every year. Okay. The next is technology is very important to improve the food productions. The third is IoT is one of promising technology to deploy everywhere. So not only in this field, but it can also deploy in everywhere. And the last is IoT business has very wide opportunity, because we know that so many companies, so many big companies already try to enter this business and trying to sell their product with their own platform. So I think it's our challenge also as an electrical engineering persons to come to go with this project. Okay, that's all from me.
Okay.
Putri, thank you very much.
Okay.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Dr. Arif, Raden Arif, for presenting this interesting topic. And for all of audience, if you would like to ask a question, please raise hand, and I will call on you to ask the question. Or you can also put your question in the chat. Okay.
Okay,
Okay.
I'll read. There is a question from Pak Effendi Dodi Asandi. Okay. The first questions, okay, in your presentations about IoT in agriculture, how does the system of technology can help the government or farmer to increase agriculture products? Okay, this is a very, very important questions. Actually, our government always says that trying to implement technology, okay, for the agriculture, but actually they don't really know what kind of technology that's suitable for the land or for the agriculture improvement in Indonesia. That's our challenge. Actually, I have been invited to the from government of Batu to discuss about the agriculture technology, and usually, fortunately, there are some younger people that actually they call themselves as petani millennial, okay, or millennial farmers. They're very interesting with the technology, and they try to use the technology to implement itself. That's why when we try to discuss, of course, the implementation of the IoT need really tested in the field, because usually the farmers thinks that the implementation of technology is very expensive. Of course, we know that the implementation of technology is not a cheap area. It's not an easy way, but as long as they can involve with the development of the system itself, because however, we as electrical engineering people, we don't really know about the problem. So by discussing with them and we understand about the problem from them, then we can give better solutions. For example, the easiest solutions, the most easiest solutions is how to bring the automatic irrigations for their crops or from grey. That's one of the important. And of course, as I show you that we have the real proven that the farmer itself says that after using some solutions that we provide, they have they already increased the production. Of course, we need to measure it not only in, because we are already working on the about 1 year. We need to keep improvement, because we need to communicate deeply with the farmers itself. Okay. The second question is, if this system can help them, do you have a data, or chart diagram in effect IoT in agriculture, and especially in Indonesia? Okay. I'm sorry, but I have no data for all Indonesians. Okay. But I try to start from the small area first. Okay, so we have some friend in Batu area, which is have some crops like bunga krisan, anggrek, bunga jambu kristal, etc. Okay, so we try to build build solutions for them. We try to ask what is the problem of them. For example, they have a problem to measure the NPK nutrient. Okay, then we try to bring them solutions. Second, they have a problem how to irrigate precisely, because usually they just send water through all area, even though the water the soil is already wet, but they keep also send the data. That's the second problem. So that's why I don't have whole data, but I try in the small area first. If it works, then I hope it can be improved to another place. Okay. Third, with applied the IoT agriculture, when our country can stop import fruit. Okay, that's a very, very good problem. But I already discussed with my friend in Batu. He's actually, as we know that apple Batu now is decreasing, right? We all know that apple Batu is the popularity is decreasing. It's I think we easily to find the apple Washington than apple Batu in supermarket. What is the problem of that? The problem is the land is destroyed when the farmers of Batu trying to put more nutrient, more pesticide to improve that. Then the reality, then the fact is their soil is destroyed, and they cannot have harvest as they requirement. That's the problem. So some of the millennial farmers, they understand, they want trying to produce the good quality of the fruit, but in sustainable way. How it is? Using the organic system. Organic system actually they don't only use the what we call nutrient from the fabric, but they can develop their own nutrient by using, for example, dead body or something like that from the leaves, from something like that, and they try to build it. And we can also measure the result of their own organic nutrient. The quality is not different with the nutrient from the fabrics, but of course it's more sustained because it's built from the natures. It can capture by natures, and it will not destroy their soil itself. Okay. So they try to. Okay, the fruit actually, I heard from my friend that the fruit that he imported from Japan, from China, for example, is it really clear with what we call some of the mix, what we call it, pengawet. I'm sorry, I'm using. The reality is they use also that particular of pengawet. So that's the real. But usually Indonesia regulatory is not as strict as in outside. So the fruit from outside can enter Indonesia. But however, the problem is the production from Indonesia itself must increase to supply the demand of that. Okay. In your project farm type with small size, have you compared your system with growing crops in soil directly with the same direction? Okay, with same dimension. Yes, because if we try to measure, of course, we cannot reject that the soil that created by the God is is the best area for crops to grow. But we can try to bring the environment similar with the soil itself. The important thing is if the soil, the crops require the nutrient that they need. So that's why we try to build something like that. The problem with soil dimensions, because we cannot create the soil with the overlay by others. Okay, but with this system, we can create the vertical cultivation. So it will be very efficient than if we plant at we deploy at the plants. Okay. The fifth questions, you give us example of the production of jambu crystal is increased after IoT, but the price of fruit still expensive in my city. Yes, of course. The problem is always a supply and demand. Okay, the first is supply and demand, and the second is how the fruit itself is managed when it grows. I have discussed with the by using by knowing the farmers in Indonesia usually doesn't know how to build what we call a sustainable system for their own land. That's the first problem. And second, they doesn't know about the supply and demand system, because it's very important because for them. That's why some of the trainings from the government for the agriculture is also giving about that things. Okay, so the problem of the price is still expensive because I think because the supply is still less than the demand. And the second things, if you using organic materials to build, then of course the price is more expensive. But in current days, there are so many consumers that choose the product with the good quality. Good quality means yes, sometimes it's developed by its growth by the organic or using the sustainable. It has the better price, of course. Okay, that's all, Pak Dodi. Okay.
Okay, thank you, Mr. Ran.
Okay,
Thank you, moderator.
Second questions,
You're
the concept
welcome.
of
Okay.
movable soil nutrient measurement stick is interesting. Can you explain what kind of sensors it to mine the chemical needs? Okay. Okay. Actually, maybe you can buy the NPK sensors on the internet, right? Actually, in electrical things, usually we just try to compare the data to electric and the sense by it. Actually, I also buy the sensors on the internet. Okay, you can buy on the Alibaba or AliExpress or something like that, and to build it by yourself. Of course, the demand of this device is very big because I just we built some of this device and bring to the farmers at the Batu area, and they trying to when they invited by the government, they try to show it, and then so many users that trying to ask. Okay, so we try to actually some of them still developing for the patents and the haki, right? But that's very important. The important thing is our farmers need us to back up them with our solutions. Okay. Okay, so of course, I'm not really know about chemical itself, but maybe we can discuss with our colleagues from MIPA or from instrumentasi or something like that to build the more precise device or more precise sensors to measure the land conditions. Because what I'm experienced with the device, it's not really measure the the measurement of the value, but at least it can detect what is the difference between this area and that area. So I have to try. My friend already proven to me. Okay, so he tried to step the device to one jambu trees. Okay, steps, and it shows that the K value, K nutrient, kalium nutrient is higher than others. Then he said, try this fruit. It must be sweet. Then I try. That's right. The fruit is sweet. So the farmers usually understand if the K is higher than others, what will happen with the fruit? If N higher, what happened to the fruit? That's why we need to support them, because the use case and the problem, they already understand about the things, but usually they don't know the solutions, how to make the things is automatically. Yes, okay. Okay, that's from Pak Oki. And the next from UC Rizal, I think your presentation is very interesting regarding many sensor user. Whether the implementation for farming is very expensive, I think the solution is by control method, like model prediction control, like many pipeline, expensive and too many sensors. So the idea is to just use like some kind of sampling or limited sensors, and then use the model predictive. Okay, that's good. Good solution, but so when you're trying to just try to, maybe you can read some solutions from Microsoft. Microsoft also have the solution for agriculture, and also AWS. They're not really sampled. They're not really taking its data from every nodes, but they try to create like comparisons, or they just sample some locations, and they try to calculate within its data, trying to interpolate between those results. And that's I read the paper that they say that it works. So I think that's also possible if we try to use that case. Okay, Bu Ika Nurna Samsiana, do you have experience using free platform of the IoT? If you have, how many total data can storage on the cloud? Okay, actually, if you ask about how many data, then the answer is how much you can pay for the data, because usually the data is unlimited. Okay, so it's usually if you're using the free platform, then they provide usually only a couple data. For example, one platform only support 5,000 data a day. Another platform can support 25,000 data for a day. But if you use the paying solutions, then I think there will be no limitation for that. That's the important thing, because the more you pay, usually you get more space, but and the price of is not linear. So maybe you need just to add 1,000, then you can get double or triple or as well. Because as I know, AWS provided some. Maybe if you are from university, you can just request the free credits from AWS. Just ask one of usually like in UB, we have one of our lecturer from, maybe if in case UB, we have a lecturer from the Philcom that representative of the AWS, and I can request the classes for me. Okay, I can create the class, and I also can invite the students, and each student will get a $100 free for the AWS cloud. So I think many universities already have that kind of the solutions. That's my answer to Ika. I hope it's answer your questions. Okay, would it be feasible if local university establish data sync middleware for IT requirement? Okay, that's a very good question. I always think that maybe if we can collaborate. Usually, my students is using Blink. Maybe you all knows that what is the Bling. Bling is a middleware and also have the mobile applications for that. But the problem is Bling is not developed by our countries. It's we just use the server. The question is, what if we are trying to collaborate with how many university? I think we can collaborate all university in Indonesia. Maybe we can try to collaborate to university or something, trying to build the platform for the IoTs. Because as long as I know, the IoT platforms is providing by business company, the big company. That's also the requirement business equipment. In fact, usually we just requirement the platform for the students for their project, for example, for the final thesis or the final exam, something like that. That's why it's very interesting. It will be very interesting if we can collaborate together to build a platform. If we build an IoT platform, I think it will be open. It can use for the agriculture. It can use for the maybe for industry, for the street light, for the environment, everything. But it created by ourselves. Of course, we can ask our students to collaborate together to develop itself. Maybe we can discuss with our friend from maybe from Polynema or from UB or from ITS, from the Philcom or computer science. They can develop itself. Okay, thank you. The last, thank you for the presentation.
Excuse me, this is the time is finished, but if you have a time, you can finish it until 11:30. Maybe you can you have a time, Mr. Raden?
Yeah, okay. I think there's
Okay.
some interesting question.
Yeah.
So there is some very, very interesting question and suggestion.
Okay.
Maybe we can collaborate.
Okay.
Collaborate
Thank you.
together.
Alexi.
Okay, how and to ensure the condition of agriculture land is certainly what to find out the soil quality of the sensor you are using, and how is the feedback if conditions are not as expected. How to ensure the condition of agriculture land is certainly wide to find out the soil quality of the sensors you are using, and how is I'm sorry, I'm not really catch up what is the meaning of the wide here. Maybe Puput can try to explain.
Pak Puput, Mr. Puput Dani Prasetya.
Okay, maybe if no explanation, I will try to move to Pak Rusli. With your IT system, can it detect what plant can grow on a certain type of soil? Okay, good questions, Pak Rusli. Actually, our system just try to measure about the NPK, because the NPK is very, very important nutrient for almost all type of crops. But of course, there is a more what we call hara micro, which is different between one soil and other soil. But this is the good questions, Rusli. I think we still starting to collect the data, but when we data for we are trying to implement with the jambu kristal, second with the bunga krisan, which is also try to check the soil itself. But maybe after we have data from various type of the crops and various type of the soil types, maybe we can develop things that you try to ask. So I think it's very, very interesting if we try to snap the device and we can know the profiles, and it will be come out with suggestion that, okay, it's better to grow, for example, jambu crystal, or it can grow rambutan or something like that. Because not only the soil conditions that impact to the soil's growth, it also the wind, it also the temperatures, it also the humidity. That's why, for example, coffee is not good in the low land area, something like that. So that's why we need to measure not only the soil, but every aspect of the conditions that we can grow the plants. Next, thank you for the presentation. I heard some IoT bots cannot support data encryption because of some limitations. Okay, that's a good thing, because from Abi Hurairah. Yeah, that's right. Because of course, each module have its own computations performance limitations. But if you try to deploy something like the encryptions, maybe you can just use the small the algorithm that not require not so many computations power. You can use them. But if you're using something like a Raspberry Pi, I think it's enough to build. But of course, it's not like AAS 256 and sectoral. It used so many resources, but in the fact you're not really requirement that kind of encryption to build. That's why, like I said before, that you need to understand what kind of the processing that required by the IoT system, and then you can choose which one is the best for the solutions. Okay. Okay. I think that's all, Bu.
Okay.
Yeah.
Thank you very much for your time, for your answer, and then thank you very much for your question for the audience. Okay. Abi Hurairah. Okay. Okay. For documentation, please turn on your video. Thank you from Madam Ika, Madam Isdawimah. Okay. There is Pak Aziz, Ibu Muslisa. Okay. Mr. Yusi. Cek, jenengan ya, cek foto. Foto. Okay. 1, 2, 3. Okay. One, two, three. Next. 1, 2, 3. Oh, yes. Okay. Thank you for Mr. Sing Yuan. Okay, Mr. Sing Yuan. Udah. Sudah deh. Sing Yuan Mio. Udah kah? Okay, finish. Okay, for documentation. Thank you very much again for your time and participation, especially Madam Ika, Madam Isdawiyah, Mr. Dodi, Mr. Xiangjian, and another audience of this session. Thank you very much and goodbye. Okay.
Thank you.
Thank
Yeah, you're
you,
welcome.
Rosemary. Goodbye.
Bye.
Thank you, Pak Fauzan. Thank you, Bu.
Thank you. Ya.
Stay.
Boleh lip ya, Putri ya?
Ya.
Oke,
Ya,
izin dulu
boleh
ya,
lah.
Putri.